I'm Norm Santich from Landsat, and I work on agricultural applications of remote sensing such as pastures from space and others. And so today I'm going to give an overview of where the season's at and how we can predict the future from pastures from space, and give an overview on what pastures from space actually is. So last year was a pretty good season, and first half of July, this is what the situation was in terms of the green feed on offer. So you can see that the purple pixels, well, the legend's over on the right hand side here, so the purple pixels are where your feed on offer is greater than 1.5 tonne per hectare. The red pixels, which there's not too many of, are less than 50 kilos per hectare, and you can see all the other colours in between. So that was about a year ago. What about last week? That's the situation right there. So this isn't saying that the whole wheat belt's growing annual pastures. This is saying where there are annual pastures on that map, that's what the green feed on offers level is at. And where did all those purple pixels go from the previous slide? So yeah, once again you can see all those areas in red are growing at less than 50 kilos per hectare, if at all. But down through here where it's the lighter greens, this mouse is pretty hard to use here, is between 100 and 500 kilos per hectare. So that's just comparing first half of July this year with a good season last year. What about historically? So we've got imagery in the archive going back to 2004. So when we look at how this time of year, so in this case it was last week, the first half of July, how does that compare with all the growing seasons going back to 2004 at the same time of year? So the red pixels are saying all other years at that time of year have been greener than this one. The brighter purples are saying none of them have been greener. This was the greenest year. So all this perennial vegetation through here, that's doing really well because of all the good season that we had last year and all the rain that we had earlier on in the year. Whereas the red areas, so particularly Darrigan, Dalwallinu, Mount Marshall, and down here at Kojonup, West Arthur and Boyup Brook, you can see that they're having the driest season at this time of year since 2004, and maybe even longer, but that's 2004 is as far back as the imagery goes. I'll just wait for the camera to go. Yep. And have we seen this before? I reckon yes. I was looking at this paddock, which is at the Muresk Institute up at Northam, and the black line is the total dry matter production for this year, and you can see all the other years going back to 2004 have been turned on. And I saw the black line and thought, oh, what does that look like? A bit like this one, which is the yellow curve of 2006. And most people remember what a shocking year 2006 was generally. So when I saw that, I got a bit nervous, and I was actually talking to a farmer back in February, March, and says, this is starting to feel like 2006 all over again, maybe even 2015, where you've got that stop-start. But it has actually started raining now, so we'll see what happens and where we go to from here. So what is pastures from space? Actually, before I talk about pastures from space in general, where was it actually growing last week? So pink is, you can either interpret it less than 10 kilos per hectare per day or not at all, 0. But you can see that it's growing along the coastal western fringe here from Mandurah down to Augusta, and around about Albany and Esperance is looking like it's having a not too bad a season. So this sort of information has been used in the past, like in bad years of 2006 and 2010, for farmers to actually get on the phone, right, look up where it's actually growing, sell the sheep there, or actually lease a property or buy a property and move the sheep onto them. And I've had a fair few farmers telling me using that they've been able to sleep at night during a bad season, like especially in 2015. So what is pastures from space? For me, it's all about where is the grass growing, how much grass is growing in each paddock, how quickly is it growing at the moment, and how much has it grown in the past. The model was developed by the CSIRO back about 15, 20 years ago. The Ag Department went out into the actual paddocks, did all the ground truthing, all the cuts, calibrated and validated the model, and Landsat coordinate the satellite imagery download, getting the climate data in from the Bureau, getting the producer paddock maps in, and integrating all of it for what we're about to see now. So for the general public, they've got two options. They can go onto our demonstration website. In fact, I'll just go back to that. over here there's a view our demo farm. So if people aren't sure about how to use the technology, it's an online tool. They can actually click on this view our demo farm. That'll take them to the Muresk Institute, and from there they can get access to a lot of freely available data. So they can turn on the pasture growth rate imagery, as you saw in the previous slide. They can have a look at the greenness as measured from satellite. They can zoom out, pan across to their property of interest, zoom in, and have a look at what's going on. If they're lucky enough to live around the Muresk Institute, and I didn't say this, they can actually turn on the high resolution imagery and have a look at what's actually happening within a paddock. And I'll get to that in a bit. So as I said, it's a pretty simple online tool, so pfs.landgate.wa.gov.au. And so yeah, if they want more information specific to their individual paddocks, they can actually subscribe to a service, digitise each paddock of interest into the system. So it'll cost them $99 as a setup fee. That'll get their historical data processed, their maps online and everything up and going. And then depending on how much area they've actually digitised all up, you can see the cost structure. So 0 to 500 hectares is $200 a year. 500 to 1,500 hectares is $410. Or they can pay more for the high resolution imagery option. So once they've got their paddocks into the system, I back process the historical data, and then for every paddock for every week going back to 2004, we tell them what the pasture growth rate is, what the feed on offer is, what the NDVI is. And NDVI is a term that you'll hear a bit. Pretty much it's how we manipulate the satellite imagery to highlight how green is it on the ground. So 20 is essentially a bare paddock, 80 is a fully green cereal crop. So over here on the left you can see every paddock that they've got in the system is summarised, so you can sort it whether it be alphabetically in terms of which paddock's growing the fastest, which one's got the highest or lowest amount of food, or which one's changing the most. For every paddock there's also a graphing tool or and also a stocking rate calculator. So you can see that each paddock in the system for the week of choice is coloured up according to its pasture growth rate. So these brighter pink purples look to me to be about 70 to 85 kilos per hectare, whereas the darker are growing at about 65 kilos per hectare, plus or minus about 5. So they also get access to the MODIS, the pasture growth rate image, so they can see the variation across the landscape, and they can zoom out to a continental level to see what's happening, as I showed before. One thing to note, these pixels are 250 metre by 250 metre square, so about 6.25 hectares. So yes, it's coarse, but the satellite goes over once or twice a day, so we actually update the information every week. And because we're able to do that, we can get some pretty good historical time traces. So you can see where the season's at, where it's heading, and how it compares. We also generate the green feed on offer per paddock. So once again, the purple paddocks are greater than 1.5 tonne per hectare. The blue is between 1,000 and 1,500 kilos per hectare. And we also show the NDVI per paddock. So how green is the paddock? How green does it look from space? Now, I never really saw the value in supplying this information. 20, yeah, it's bare, 80, it's really green, 62, what does that mean? Well, the MLA are actually introducing an app in September in collaboration with the University of New England. So they've actually gone out and done the pasture cuts for each individual species. So you'll be able to say, right, I'm growing fescue or capeweed or clover or ryegrass or phalaris or whatever, put in the NDVI for that pasture species, and it will tell you what the feed on offer is. Because when the Ag Department went out and did all the ground truthing, it was only for species specific to WA at the time, so stuff like capeweed, clover, ryegrass. But over east they grow a lot more cold tolerant pasture species. So now with the MLA University of New England app, it'll just broaden the range of what the feed on offer and the NDVI offer. And you can also see the MODIS NDVI greenness image, so how green is it, how does it vary across the landscape. You can zoom in, zoom out again to the continental scale. So I mentioned we've also got the charting tool, so for every paddock we offer, up the top you can see the pasture growth rate, the feed on offer, the NDVI, the total dry matter production and the rainfall according to the Bureau of Meteorology. So this slide's got every year turned on, and you can see, those years that have had a pretty decent autumn. It slows down a bit as you come into winter, and then the spring really makes a difference. So a booming spring or an early failing spring, depending on the year. It's also graphs up the NDVI, so how green is it? So you can see that, during summer, not very green at all, and then as the season breaks, you can see those curves really pick up. So you can see the early breaking seasons or the later breaking seasons. Now, most farmers that I talk to, this is where they're getting the real value and the real power from Pastures from Space now. So looking at where the season is at the moment and how does that compare. So last year, in 2016, I gave this presentation back in April, and we could see that for this particular paddock, and you've got to remember that this data is specific to a paddock, so it's not representative of the whole state, it's just specific to the paddock. So for this particular paddock in Arthur River, we could see that it was paralleling 2008, and as you can see, 2008 ended up a 10-tonne season. 2006 wasn't growing as quickly, so eyeballing it, we said, it looks like it's going to level out at about 9 tonne, and sure enough, where's that tracking? It grew just over 9 tonne. So knowing that, the farmer was able to work out, right, what's the carrying capacity for that paddock back in April? So that's a pretty powerful piece of information right there. This season, as you can see, started off early, flatlined to nothing, and then May started off again. So we'll see where that tracks relative to the other years. I mentioned the high resolution imagery. So NASA back in 2013 launched the Landsat 8 satellite. Now this one's got 30 metre pixels. So as you can see, you can start to see what's really happening inside a paddock. So the area of interest to note is this paddock here. So you can see that on the western part of it, it's growing not too badly according to the legend, whereas the eastern part, it's pretty well struggling. Now this farmer saw this, worked out what is the area of that part of the paddock that's actually struggling, went in and put in Flexi-N, and then 16 days later when the next image came out, you can really see the improvement that just fertilising that part of the paddock made. And just by doing that alone, he saved himself $400, and he was so excited he rang me to tell me about it. He's also using this sort of data to see where are the sheep grazing within a paddock and where are they leaving alone, and then once he moves them off, what parts of the paddock are recovering quicker and which parts are struggling. You can also zoom out to see more of a landscape, check out how your neighbours are doing, and if you can see that their wheat crop's doing a lot better, you can just go and ask them and say, hey, what are you doing differently? I'm looking at the imagery and it's looking much better than what I'm doing. Got any advice? So I've taken this higher resolution imagery and also produced the pasture growth rate information. So you can see the variability across the paddock and also the green feed on offer. So we've also got the stocking rate calculator, and this is based on the MLA's one, but the difference with our one is you can click on an individual paddock and it will bring in what's the current pasture growth rate and the current feed on offer. So it takes the guesswork out of it, and all you really need to do is either specify, right, what are you grazing, what do you want to graze down to, and either how long are you going to graze the paddock for with a set number, well, with a calculated number of stock, or how long can I graze a paddock for with a given number of stock. So it's got the two scenarios there, and I think I'm about out of time.
I think Norm's shown us some very interesting maps there, and I did hear the intake of breath on the second map, but I think the real exciting thing is that Pastures from Space has really evolved in providing a lot more capacity for people to work out how to manage their pastures and what they're getting from their pastures. So it's really quite exciting, and I think we should start to see that really grow, and with that high res imagery. Yep. I think that's really important.
There's now 2 satellites up there with 10 metre pixels, and I've got most of that back processed across the whole agriculture zone on the continent. So
that's a lot of data.
Yep. So yeah, it will continue to evolve. So watch this space.
Would you like to join me in thanking Norm for his presentation?